1, part 2, and this is the final part of synthesis. So first, let me recap the topics what all we have done in the last two classes. So what all we have done in the last two classes: introduction on in synthesis. Introduction of synthesis in the sense what is a synthesis? What is a synthesis? The process of converting high level description language into a gate level language. Gate level netlist is known as a synthesis. And next we have seen through synthesis flow. What are the inputs we are giving to the synthesis? So what are the inputs we are going to give to the synthesis? Like netlist. 1 minute. Let me share it once again. So what are the inputs we are giving to the synthesis? We have learned next steps to optimize the synthesis flow. So what are the steps like genus synthesis flow, sync mapping, sync generic, DFT insertion. Next steps involved in RTL designs. What are the steps involved in RTL design? EPS, RPS, time based RPS, and STC constraints. That means the constraints which are written for the process to get to move on. So what are the constraints like set inputs, create clock, generated clock, all the constant virtual clock, everything we have seen in the last class. So in today's class, I'm just going to explain you so which type of constraints is used for which type of command. So like we are having a different n number of systems and different n number of inputs, right? So for each and every input or for each and every command, how to use, how to write a command. So we are going to discuss in this class. So I have told you we are having a many STC constraints, and I explained you like nearly 10 constraints like create clock, virtual clock, create generated clock, set clock latency, set clock uncertainty, set input delay, set output delay, set false path. So these are the few constraints which I have explained in the last class, but I didn't give brief or to the depth of these constraints. So today I'll be explaining you how to write a constraint and why do we use a constraint for a particular part. I'm just going to explain you. So first one is create clock. So why do we use a create clock constraint? Constraint is nothing but it's just a command. See, for any C programming language, Java, C++, whatever the language it is that we will be using some commands like Linux, Unix, something. It will be using a command to go to a next step or to go for a workspace. In the same way, here in a synthesis, CDC, STM, whatever the mechanism, someone has talked. I didn't get you. Voice is not clear. Okay. So what are the constant? I'm saying constant or nothing. It's just normal command which we are using to do some function or to do that process. So create clock. Why do we use a create clock in synthesis? We use a create clock to define its character, to create a clock, and to know the characteristic, to define the characteristics of a clock. Characteristics in a nothing but each clock is having a period, waveform, time, everything will be there. No? So to describe those characteristics, we are using a create clock. So how do we use that command? Create underscore clock. Clock, no? Create underscore clock. Period. Here we will be mention the clock period. Here I didn't mention because as it is an example period, in the sense we'll be having a clock period, no? That we should mention here. And next, waveform. Next, name of the clock. What is the clock? See, for each and every clock in an when we go for an product based company or when we go for an industrial level, we'll be having for each and every clock some particular name, right? So that name we should mention. And get port clock. So what is the clock here? The clock name should be mentioned. This is how we will be using a create clock. How do we use a command here? Create underscore clock underscore period. Period you should mention from the clock which you are taking. Waveform you should mention from the clock which you are taking. Name of the clock and get ports. And next one is virtual clock. Why do we use a virtual clock? See here, for the virtual clock we will be not having any source. For create clock or any other clock, we will be having some source and destination. Source which gives, destination which takes, right? So here, for what is the meaning of virtual clock? In the sense here, for the virtual clock, we will be not having a source clock. Source clock in the sense we'll be not having an input. but it exists in a design, and we used to design we used to constrain a block. So virtual clock is mainly used, it is not physically it doesn't exist, but we use it for creating or for constraining a block. So how do we write for a command, how do we write a command for virtual clock? Create underscore clock period. As we know that for each and every clock we'll be having period, right? So that we should mention here name of the clock, and so that the clock name the clock name you should mention here. That is the virtual clock command. Next we are going for create generated clock. So what is a create generated clock? It creates an internally generated, that means it internally creates, like from flip flops or from registers, the clock is created, and that clock is said to be as a created clock generated. So it might be divided by 2, 4 and 3. So how do we use a command for this create clock? Create underscore generated underscore clock divide. If it is divided by 2 clock, we will be using divided by 2. If it is divided by 4 clock, we will be using divided by 4. And source, from which source it is coming, that means like from which flop it is coming or from which register it is coming. Clock divided get register clock divided, you have to mention those names. So this is the command which are using for the create generated clock. See, for interview purpose we are no need to like learn complete to the depth of the clock. So interview purpose they will be asking like what are the STC constraint, and they may ask you like you can write any two commands for the particular constraints. That's it. So no need to learn a depth of to that. You can just learn what is the use of that constraint and what is the how do we write a command for that particular constraint. If you learn that, it's enough for the in the point of interview purpose. When you go for an industrial or when you go for a real time experience, at that time these all constraints are very useful when we go for a synthesis domain. The next one is clock latency. Set clock latency. Clock latency means what is that? It is defined as the amount of time taken by the clock signal in traveling from source to sink. Here you may have a question, what is the meaning of sink? Sink is nothing but the flops are being triggered by the clock. Since the flops will be triggered from the by the clock signal. So that condition is said to be a sink. So how do we define a clock latency? Clock latency is nothing but it is defined as the amount of time taken by the clock signal in traveling from source to sink, that is defined as a clock latency. So how do we write a command for the clock latency here? Set clock latency source, from which source it is, and bread clocks and name of the clock. Is it a sys clock, F clock, mini clock will be that. So that clock should be mentioned here. And next one is set clock uncertainty. So what is set clock uncertainty? It is specifically uncertainty of a single clock between two different clocks. So how do we define a set clock uncertainty in the sense? See, here we'll be having a two flops. Like for two flops, we may have a single clock, or for two flops, we may have a two different flops, two different clock. Like so, to the any uncertainty of clock in between those two flops is defined as the set clock uncertainty. So, how do we write a command for that? See, set clock uncertainty. Set up rise. Here the clock will be having a rise and fall. We will be having a rising as well as a falling, right? Here will be mentioned rise clock, from where it is rising, clock 1 2, and from where it is falling, at which particular nanosecond it is falling, and we have to mention the clock period. So that is how we will be writing a command for the set clock uncertainty. Here in this page I have explained you create clock, virtual clock, create generated clock, set clock latency, set clock uncertainty. So why do we use a create clock? To create a clock, to define the characteristics, we use a create clock constraint. And what is the, how do we write a command? Create underscore clock underscore, we have to define its period, waveform, name of a clock, and port of a clock. Next one is virtual clock. Virtual clock in the sense it does physically doesn't exist, but we use it for a constraining a block. So how do we write a command here? Create underscore clock underscore, and we'll be mentioning its period as well as clock name. Next, create generated clock in the sense internally it will generate a clock like it between a flop, in between a registers, if it generates, and that clock is said to be a create generated clock. It may be divided by 2, divided by 4, divided by 3, it may be a different clock. So that everything should be mentioned when you write a command for it. Next, set clock latency, it is nothing but what is a clock latency? So it is nothing but the amount of time taken by clock signal to be synced. So what are syncs? Syncs are nothing but when the flops are triggered by the clock by a clock signal, that is said to be a sync. And here you should mention the clock latency and from which clock and what is it, it should mention. Next, set clock uncertainty. Here set clock uncertainty in the sense in between are two flops. If you have any single clock or two different clocks, there you'll be seeing a set clock uncertainty, and there you should mention set up by which time it is setting up, rise time and fall time you should mention in the set clock uncertainty. And next one is set input delay. Set input delay, it is nothing but it defines the arrival time of an input related to a clock. That means it defines where, see, while it mainly depends on when a clock is entering during the arrival time, in that input and that relative input is defined by a set input delay. So what is a command is used in a set input delay? Set input delay, and with how many times, like with how much time it is getting delay, that is 1.41. That is it's your wish. But for example, I gave you 1.4 clock underscore and falling of clock or rising of clock, you should mention and give maximum. Maximum in the sense it is a setup time, minimum in the sense it is a whole time. You should remember always while using a command, if you mention it is a maximum setup time, that indicates setup time. If you mention a minimum in the command, that indicates hold time. So here you should note down that point. Next, set output delay in the sense when it is an output side, if you get an any delay that is related to set output delay. Here same set output delay, you have to mention for how much time it is output delay, clock name, fall time, and if it is a maximum you should mention maximum, if it is a minimum you should mention a minimum. Next, set false path. Set false path in the sense it identifies the path that considered false and excluded from the timing analysis. That means some of the paths were like which are existed in the design. Topologically they are existed, but we will be not using in the real time. Those are said to be as a set false inputs or set false path. In that cases, how do we use a command here? Set underscore false underscore path from get clock. So which clock it is getting and from which reg it is getting, we should mention. So these are the commands or these are the constraints mainly we will be using in a synthesis. Then some of the commands are also there which we will be using in a synthesis, but these are the very important commands which we will be using in synthesis as well as in STA. Also we will be using in some timing analysis. So these are the main STC constraints which we are used. And next, the final one I have shown you inputs and how to optimize the synthesis I have shown you. Next, what are the constraints? Next, what is synthesis flow and genus synthesis, everything I have. And the final one is output. So what are the outputs are there? Output will be getting as a netlist. Netlist is the main primarily output. And next, what are the reports? Reports are generated. What are the reports? It contains timing reports, power related reports, area related reports, leakage related reports. Everything are present in the synthesis output. So this is the complete topic regarding the synthesis. Here you may have a different interview question like I'm just recalling you like how do you get an interview question, like what they may ask you like what is synthesis, what are the inputs of synthesis, what are the tools used for synthesis. Next, can you please explain the steps which are used for optimization of synthesis. Next, could you please explain any 2 or 3 STC constraints which are used for synthesis?
Why is it not down?
Now is it clear?
Now it is clear.
Yeah. Yes. What are the outputs which are present for the synthesis? So these are the questions which are related to synthesis. So this is the final part of the synthesis. This completes the topic of synthesis. So if you have any question, you can just raise. I'll just let you know. Yes, SDC stands for Synapse Design Constraints. Someone have messaged in a chat box. Yes, SDC stands for Synapse Design Constraints. So you can have like different questions like what is a synthesis? You should be able to answer. What is it? You have to answer. What is the definition which I have told, which I have told you, or which I have explained you in that? You have to explain that. Next, what are the goals of this? Is the main important question. What are the goals? Why do we use a synthesis? We use a synthesis mainly for getting a gate level at least, setting a DFT target, and next reducing the power area. All these comes under the goals of synthesis. Next, inputs, mainly inputs, .lib files, STC constraints, next text files, .mmfc files, UPF files, all were the inputs. Next, output, what are the outputs you get? Netlist. The main output is a netlist, and next reports were generated. What all the report contains? It contains regarding timing, area, power, leakage, macros, everything, each and cell usage information, everything was contained in the synthesis. Next, steps. Can you please explain regarding steps? Steps involved in the optimization of synthesis means you should explain like genus synthesis. What is a genus synthesis? Think mapping, think generic, and CFC insertion. These you have to explain them. So if you have attended for the previous class, you will be known these steps. Next, you will be having a questions like what are the steps which are involved in the RTL? So EPS, RPS, time this RPS. You can explain regarding this. You can just give an overview on that. You need to
Not
explain
like
brief on that. So you
screen,
can just your voice was breaking. I could not
screen is not coming. Screen. Share.
I should explain it once again.
Okay.
Should I want to explain it again?
Share the screen. Screen share.
Yeah. Okay, fine. So once again, I'll just give you a short overview from the starting of a synthesis part. Just give me a moment. I'll just open the document. Yes. I think many of them were joined newly. So I'll just explain you from the starting. Give me a minute. I'll just share you and I'll just give you a overview from the starting. Yes, here. See here. So what is a synthesis here? Synthesis is nothing but it's the process of converging high level description language into a gate level netlist. Here we will be having a high level description language. So to convert that into a gate level netlist, we will be using a synthesis. I asked you next question, what are the goals of synthesis? What are the goals of synthesis? The goal of synthesis is nothing but it is to generate a gate level netlist and to design to meet the specification like area, power, and timing requirements. Next, what is the synthesis flow? See what does a synthesis? What does mainly synthesis do? It takes input. First, it read input. It elaborates. It compiles, optimizes, and it like the last step. DFT will be done. So, what all the inputs of the synthesis? RTL code. RTL code is the main input. .lib file. .lib file is nothing but library file. SDC, synapse design constraints, and another input. UPF, unified power format, physical library, and technological library. These are the inputs of synthesis. This is also main important question. What are the inputs of synthesis? RTL code, library files, STC files, UPF, LP, LDEF, as well as TF. These are the inputs of synthesis. Next, which type of data is contained in input? See, RTL contains, it contains like I told you like these are the inputs, right? So you may have a question like what does library file contain? What does SPC file contain? What does UPF file contain? You may have a these type of questions. So let me explain you that. What is an RTL contains? RTL is contains like digital signal, hardware registers, logical operators, everything, each and every information was contained in the RTL code. And next input I told you that lib file. Lib file is nothing but library file. What does it contain? It contains the info regarding PVT cells, wires, cell delays, and other information. Next, what does SDC contain? SDC contains timing constraints, timing exceptions, fan outs, maximum area, LVT cells, SVT cells, net cells, DLS, everything information contained in the SDC. Next, what does a UPF input contain? It contains power related factors. Next, what does left file contain? It contains some physical coordinate like abstract view of the cell. And what does technological file contain? It contains like parasitic information is nothing but the information regarding to the path. So these are the inputs, these are the data which are contained in a particular input. See, if you may get like get a question like what does a library file contain? So what should you do?
Speak louder.
Yes, it contains. Yes, you can say that it contains info regarding like wires, loads, cell delays, everything you can explain. You may have a question like what does UPF contains? You can explain that. So it contains power related aspects, power related information. These type of questions also you may raise in a interview. So this was the first document which I have explained. What is a synthesis? What are the goals of synthesis? And what is an input which we are giving for the synthesis? Next, what are the data is contained in the input? This is the first slide of first PPT which I have explained. So let me go for the next one. Steps which are used for optimizing the synthesis. See, synthesis in the sense if we give inputs to the tool, we do it to directly and it will give output to us. No, some of the steps were involved. See, so for example, we are the human beings will be having on each and every step to do and each and every functionality, right? So in the same way, when it's come for an hardware sector, when it's come for any domain, you will be having the steps to optimize. So what all the steps it is involved in the synthesis? Let me explain you here. So first what it does here, you can clearly see it, read input. So first what we will do for the tool, we will be giving inputs. So what all the inputs? RTL, lib file, SDC file, UPF file, left files, everything will be giving some inputs, right? So after taking input, what the tool does? The tool, it will read the inputs which they have given. So what the tool does, it will read all the inputs, like all the inputs were present or not. If any inputs are missing, it will just raise the error. Like that, what the tool does, the tool reads the inputs. And next, what it does, it will elaborate. Elaborate in the sense, it will check for each module in the design and it will check for whether the instances were correct, whether the undefined modules are present or not, whether all the entries were not. Each and everything was done in the elaborate process. And next, what the step goes, sync generic. And what that sync generic involves, it will take fully elaborated it will take fully elaborated design to the input. In sync generic, what will be the input? The elaborated design will be the input. And what it does, it will design a synthesis into netlist and optimization of data paths like adders, mux, multipliers, shifters, everything was done in the second step, that is sync generic. In sync generic, what happens? For sync generic, it takes input as like elaborated design. And after taking elaborated design, what it does, it starts optimizing the paths and it also starts optimizing the components like adders, marks, multipliers, shifters, and etc. Next step after sync generic was passed, and it will enter to the next step, that is called sync mapping. So what does the sync mapping do here? Sync mapping here, it takes input as a from the sync generic, it takes input. So what it does here, it just maps to the generic gate. See, it will be having a normal programming, like we need a gate level netlist. So what it does, it is according to the design, starts mapping to the generic gates, to the technological library, to the mapping of any other logic. Everything was done in the sync mapping. So after the sync mapping passes, what it does, it goes for the sync optimization. What here sync optimization does, it takes fully mapped design, fully elaborated design it takes, and what it does here, it starts incrementally optimizes the timing, area, and power. So the main motto of synthesis is to mainly focus on like timing, area, and power. So in sync optimization, what does these steps do? It takes a fully mapped design, and after taking a fully mapped design, what it does, it slowly increment, it slowly starts to optimizing the timing, area, power, and also it optimizes like WNS, TNS. WNS is nothing but worst negatives like TNS is nothing but total negatives like. When it comes for STA timing analysis, there I'll explain you clearly regarding WNS and TNS. Next, if after sync optimization get passed, and the final stage of the synthesis was DFT insertion. So DFT targets, insertion of DFT targets will be done in this final stage. Next, after this, we will be having a RTL, right? So RTL will be also involved in few steps like EPS, RPS, and time-based RPS. So what is the meaning of EPS? Early physical design. So what does here, when we run this step, we will not have any depth. So when we run this RTL step, we will be not having any depth, and all the steps were involved. Like all the steps were involved in the sense sync generic will involve, sync optimization will involve, sync mapping will be involved. Everything will be involved in the EPS. But only thing is that def will not be there in this EPF. Next step is that RPS. So what is RPS? Here all the optimization of steps will be involved. Here def will also be present. And next one is time-based RPS. So what is time-based RPS? Time-based RPS, RTL release will be done here without any errors. That means all the errors were optimized in this time-based RPS. So all the RTL release will be done here without any errors. So these are the steps which are involved in the RTL design. And next one is that STC constraint. I just explained you regarding STC. So what all the STC constraints are involved here? Create clock, virtual clock, create generated clock, set clock latency, set clock uncertainty, set input delay, set output delay, set input transition, set maximum delay, set false output, set maximum output, set multi-cycle path, all were involved in the STC constraint. So this was the part two synthesis, which I have explained you. And next here today I have explained you the part three, like which all what all the STC constraints are used and how the constraint, how the command were used. Today in this class I have explained. This is a complete topic regarding synthesis. If you have any doubt, you can just raise me the question. Yes, I have just got a message. Does it also reduce the gate level logic to simplified form to reduce the power and timing? Yeah, the main motto of a synthesis is to reduce the power and timing. Why to reduce the power and timing? You may have a question. See, if you have a more area, consumption of power will be more. If you have a less area, consumption of power will be less. So if you have a more consumption of power, you will be not using that equipment or you will be not using that device, right? Everyone will be habituated to the equipments or any electronic gadgets which are very fast to move on. So that's why the main motto is to reduce the area, power, and timing. Any questions?
Any questions? Ranjit, Tejasvi, Gopal, Harsha, Jay, OS.
Can I leave now?
I have question.
Yeah, just ask.
So is the like a synthesis tool we are using the like Genesis from the synopsis? They have their own algorithm to reduce the like logic form in the gate level. Cause
Yes,
like
yes, 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 yes. for each and every like synthesis, synapses or cadence or like they have an own algorithm. So no, we are not people to set a particular algorithm. They have a own algorithm.
So whatever the netlist they are giving in the end form for the gate level description in the
Yes,
HDF.
yes, yes,
So this
yes,
is the
yes.
like the best algorithm applied for the like maximum PPA achieved, like power, performance, and area
Yeah,
after
yeah, yes,
synthesis
yes.
with that. Okay.
No. Actually, like after synthesis, it just go for an STA. Like
So that
PPA is
HDL,
not
yeah.
applied. Yes, yes.
Yeah. So
PPA is
that
not applied
HDL
for
is that HDL
a.
is the simplest form with like lowest power and lowest area and like performance is the best. Um,
Yes.
okay. So then what SPA engineer do in the like company? They have to like there's like SPA
So
engineers they have to do some work also, no?
yes. Let me like FPGA side. I doesn't have a much knowledge on that. But here I just explain you regarding towards ASIC side. So FPGA I don't
No,
know.
no.
I just have an
I'm not asking FPGA. I'm asking what does the STA, static time analysis engineer do if the like software is doing everything? Like
I didn't get STS static timing analysis.
yeah. There's like a static timing analysis engineer
Yes. In
who
static
like optimize
timing
it.
analysis, you'll just go through the timing reports. In the timing report, you will be checking for slacks like whether the slack was met or not, and whether it is in a setup timing or hold timing.
Yeah. So then
Yeah,
we
everything
introduce
will be go
buffers and
through the
inverters to
STA.
like yeah. Then
Yeah,
we introduce the
buffers,
buffers and inverters.
inverters, and
Yeah,
what are how
yeah.
many multi-bit cells were involved, how many LVT cells, SQT cells, everything which comes under STA.
Yeah, so this is done after what we get the like synthesis netlist file. This is done
Yeah,
after
after
STA is done
synthesis,
after that.
yes, after
Okay.
synthesis, STA is done. As per STA, the input was a net list. So without doing
Okay.
synthesis, we can't do STA. But because STA needs input as a net list, no? From synthesis, we get net list, right?
Yeah, because the netlist is the input tool for the physical design team to like
Yeah,
describe the hardware.
PD
Okay.
also. Yes.
Thank you. Thank you. Thank you. Thank
Uh,
you.